So make sure you have your notes out. I also want to see this sheet from you. Whether you rip it off or turn back and forth, this is the sheet of notes that you're going to get on the test. I'm just pulling up into a smart notebook document right now. Here it is. Okay. All of the scenarios I've given you so far have been one of the following. On the worksheet that you had that involved 8 problems or 10 problems, angle, angle, side led to one solution. Angle, side, angle led to one solution. And then we also looked at this scenario where instead of having 2 angles, what if we just had one angle and 2 sides? And in that situation, we looked at these scenarios where the side opposite the angle was longer than the other given side, and so it ended up giving us one solution. Today, we are going to encounter these situations where there is either no solution or there are 2 possible solutions. And that's what we want to try to do today. The nice thing is that I have this wonderful flow chart. I want you to understand that when I learned this, when I was in high school, there was no flow chart. It was just, you just figure it out. So when I was teaching, I saw that some students were able to get it, some students couldn't. And so I tried to put something down. And it took about 5 tries, but finally after the 5th try, I handed it to somebody and said, oh, now I finally understand what I'm supposed to do. Some people say that they can't follow the chart, that they find it too confusing. My response is, I get it. You can make your own then. And when you make your own, you can go ahead and use that on the test. If you don't think that this is helpful, then make your own. You don't have to use my stuff. If you like your stuff better, go ahead. That'd be fine. So let's try an example. We move back to our notes. This is called the ambiguous case, and this is the scenario. We have side, side, angle where the opposite leg is, instead of longer, it is shorter. So watch what I'm going to draw. I'm going to draw a triangle where I don't know how long that leg is, but I do know the angle. The angle A may be, say, 40 degrees or something of that nature. Okay? And I know that this side right here is, say, 12. And then the opposite side is, say, length 10. Look at that scenario. How many sides are we given? 2. Is the angle included between the 2 sides? No. If I had this angle, then the angle would be included between the 2 sides. So when you see this, the first thing you do is you recognize this as a side-side angle problem. Donkey. Got to figure it out. So I go to my flow chart, and it says side-side angle. And I follow it down here, and it says, is the side opposite the angle longer than the other given side? Or is the side opposite the angle shorter than the other given side? Let's look at this. What's the side opposite the angle? 10. Is that longer or shorter than the other given side? It's shorter. Uh-oh. That means that I can't go down to here. I've got to move over here. Side opposite the angle is shorter than the other given side. And so in that situation, you will either end up with no solutions or 2 solutions. Let me show you why 2 solutions can work out. And here's the scenario, and this is what you got to keep in your brain. There's my side. That is a length of 10, right? If I swing this leg on a pendulum, and it comes up over here, that also has a length of 10, doesn't it? These are 2 triangles. Triangle 1 is in red. Triangle 2 is in blue. Those are two triangles that have an angle of 40, a side that's 12, and then another side that's 10. We don't know which one it's talking about. Why? Because this side right here could be extending down to this side, or it could pendulum over to this side. We just don't know which one it's referring to. So in that situation, we set up two triangle solutions. We'll do an example on that. But can you keep that visual in your mind? Look, that's the confusing example. The other ones are actually quite easy. Let's look at another scenario. We will make this triangle, where we call this, again, 40, and we'll call this 12, and then we will call this 2. Sometimes you have an opposite leg. Again, if you go down the list, you see it's side angle. Is the opposite leg longer or shorter than the other given side? It's shorter. If you look in this case, it's just too darn short. I can't stretch it to reach all the way down. Now it's longer than 2. It's just 2. It can't reach the other side. There's no solution. And so in this situation, the opposite leg is just too short. There's no solution at all. And then we have this case. This is the case that we've already examined. Is that opposite leg longer or shorter than the other given side? It's longer. Notice if I try to tilt it on the pendulum, it doesn't ever cross that side again. There's no way you can make two triangles out of it. You just got the one. So if the opposite leg is longer, that's good news for us. We can just go down to here and say, yes, there's just going to be one solution. Today we will set up 3 examples, and your goal is to identify whether it's going to be one solution, 2 solutions, or no solutions. This is the most complicated part of the unit. If you could get through this, you could get an A+ on the test. No questions asked. Let's give it a shot. Whoop, we don't know how to do that. There we go. Solve the following triangles. We create a triangle. We have side, or angle A is 42 degrees. Side A is 22. I'll call this angle B, so side B is 12. I first classify what type of triangle it is. Is it angle, angle, angle? Is it angle, side, angle? Is it side, side, side? What do I have going on here? Yes, I have angle, side, side, otherwise known as donkey, okay? So that doesn't work out. So everybody see that I have that, and I do not have side, angle, side. If this was 42 degrees, then it would be side, angle, side. The angle would be between the two, but I don't have that. So what I do is I grab my helpful sheet. Side, side, angle. I then look at the leg opposite the other side. Is that leg longer or shorter than the other given side? It is longer. And so I simply follow that down. Since it's longer, I do one solution using the law of sines. I can be confident that I just come up with one. No big deal. So let's give that a shot. I'm going to solve the triangle. I need A, B, C. Little a, little b, little c. I know angle A is 42 degrees. I know side B is 12. I know side A is 22. So I'm going to use the law of sines. Somebody help me set it up. Sine of what? 42 over 22 is equal to sine of B. We don't know what angle B is. Over 12. Now, what I'm going to do is I'm going to solve for angle B. So I'm going to multiply both sides by 12. 12 sine of 42 over 22 is equal to the sine of b. I'm going to make that into a decimal. Mode, I need to be working degrees. I am. 12 sine of 42 divided by 22. And I get 0.3650. Now I'm going to ask you a question. You're going to wonder why I'm asking you this, but trust me, it'll make sense with the next problem. You just got done graphing sine and cosine on a test. What's the biggest value that sine can be? When you're marking off your amplitude, what was the biggest value that sine could be? Just the parent graph. 1. What was the smallest that sine could be? -1, right? Biggest value is 1. Smallest value is -1. So can sine ever have a value of 0.36? Is 0.36 between 1 and -1? Yeah. So let's figure it out. We'll go sine inverse of that answer. And I get 21.41 degrees. What can I now find? C. I'm going to subtract from 180. 180 minus 42 minus 21.41, and I get 116.59. Can I now find side C? Yeah. Set it up for me. What will I use? Sine of what? $116.59 over C is equal to sine of 42 over 22. And so I will cross multiply and solve. 22 sine of 116.59. And I will divide that by the sine of 42. And I get 29.40. Could you find the area? That's what we practiced yesterday, right? On your assignment today, you'll find the area again. Okay. Was this new, or is this something you've done before? Something you've done before. Let's try two that are new. We set up the second one. Let's draw our shape. We have A, B, and C. We have side A is 15, angle A is 85 degrees, and side B is 25. You tell me, what kind of triangle do I have? Angle, side, angle, side, angle, side, 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 side. What do I got? I have two sides and an angle not included there. So I have a side, side, angle situation. So I go to my chart. I look it up. It says, is the side opposite the angle longer or shorter? Which one do I have? Yeah, as you look at here, 15 is shorter than 25. So I am going to either have no solution or two solutions. We won't know until we set it up. So let's set it up. Sine of what? 85 over 15 equals sine of B over 25. I'll multiply both sides by 25. 25 times the sine of 85 divided by 15. And I get 1.6603 equals the sine of B. Earlier I asked you guys, what was the biggest value that sine could be? 1. What's the smallest it could be? -1. Can sine ever be 1.66? No, it can't. And at this point, you know you have a triangle where there's no solution. Turns out, I probably didn't draw the triangle correctly. It shouldn't have a side that goes all the way over. It should be more like this. 15 is just too short to reach. It won't make it. How do we know that? If you were to use your calculator and you were to go to second sine inverse of the answer, you can see it gives you an error. It won't even calculate that for you. So you know you have a problem. No solution. Those ones are fun because they're done just like that. Okay? You're going to have 2 of them on your assignment today. Let's go to the last one. Which one do you think this is going to be? We have A, we have B, and we have C. 20.5. Side A is 12, side B is 31. Tito says we have a side-side angle situation. Yes, we do. That's all we're practicing today. They will all be side-side angle problems. So, is the side opposite the angle longer or shorter than the other given side? It is shorter. So I therefore have, since it's shorter, I either have no solution, which I had last time, or I'll have 2 solutions. We won't know until we set it up. So let's set it up. Sine of 20.5 over 12 is equal to sine of what? B over 31. Multiply both sides by 31. Sine of 20.5 divided by 12. And I get 0.9047 equals the sine of B. Can sine be equal to that? Yes, it can. Because the opposite leg is shorter than the other given side, and because I come up with a sine value that's appropriate, at this time, I now set up 2 triangles. I know I have a 2-triangle solution. Triangle 1, triangle 2. I have A, B, C, little a, little b, little c. A, B, C, little a, little b, little c. What do we know is for sure the measure of angle A? 20.5. So I list it for both of these. What do we know is for sure the measure of side A? 12. What do we know is for sure the measure of angle B, or side B? And which angle am I solving for here? We're solving for B. Here's the problem. We have 2 answers. We go sine inverse of that answer, and we get 64.78. Here's where it will really help if you read the decision tree that I made for you and you follow the directions. Look what it says. It says, when solving for the missing angle, if sine is less than 1, which it was, there are 2 solutions. At this point, set up 2 possible triangle solutions. We already set up 2. Triangle 1 will have theta be an acute angle. What does it mean to be acute? Yep, was the angle we came up with less than 90? Good. The next triangle, triangle 2, will have theta be an obtuse angle. What does obtuse mean? Greater than 90, between 180 and 90. So we're going to find that angle right now. All we have to do, the directions say, is to take 180 and subtract 64.78. And you get 115.22. So, will C end up being the same or different for these? If we take 180 minus 64 minus 20, will that give us the same as 180 minus 115 minus 20? It'll give us different results, won't it? So we need to solve for each of these differently. So let's do that. Let's come up with angle C. 180 minus 64.78 minus 20.5. And I get 94.72. Then 180 minus 115.22 minus 20.5. And I get 44.28. Do you think side C will be the same for each one or different? It will be different. So let's find side C. Any ideas how to find side C? Sine of 20.5 over 12 is equal to the sine of what? 94.72 over C. We cross multiply and solve. Sine of 94.72 divided by sine of 20.5. I get 34.15. Does it make sense that C is your longest side? Yes, why? Because the angle is the biggest. So let's do this one then. Sine of 20.5 over 12 is equal to the sine of what? Now I'm doing this triangle. 44.28 over C. Cross multiply. 12 sine 44.28 divided by sine of 20.5. And I get 23.92. And again, that works out because C is in the middle and this side is in the middle of A and B. Yes. Excellent question. When I first set it up, I got the 0.9. I did inverse. And when I did inverse, I got 64.28. Then I subtracted that from 180 to get this one. Whatever angle you come up with, that will be the only tie between those two. That's how you connect them. Then you just solve each one independently. So we're going to practice one on your worksheet today. You're going to get today and tomorrow to work on your worksheet. We're going to do 2 examples together in your worksheet. Tomorrow will be an entire workday with a checkpoint. Question, Tito. Yes, so this angle was given, it's the same. This side was given, it's the same. This side was given, it's the same. Otherwise, the red is totally independent, and you see the blue is where we had a crossover. Okay? Good questions. Well, there we have it. Okay. So let's draw our triangle. We have A is 70 degrees. We have side A is 25. And we have side C is 26. So, of the 6 scenarios, what kind of triangle do we have? We have a side-side angle. I go to my decision tree. It says I need to check the side opposite the angle. Side opposite the angle, is it longer or shorter? It's shorter. If it's shorter, then I either have no solutions or 2 solutions. We won't know till we set it up. Sine of what? 70 over 25 equals sine of C over 26. Multiply both sides by 26. 26 sine of 70 divided by 25. And I get 0.9773 is equal to the sine of C. Let's see now, folks. Can sine be that kind of a value? Yes, it can. So am I going to have no solution or two solutions? I have two in this scenario. So we need to set up a second triangle. I have A right now is 70, and I have another triangle where A is 70. Oh, B, C, little a, little b, little c. So I know angle A is 70. What other pieces do I know? C is 26 for both of them. What else? A is 25. In my problem, what angle am I solving for right now? C. So I do inverse. And I get 77.76. Is that acute or obtuse? (77.76) is less than 90, so therefore it is acute. So how do I find the obtuse one? 180 minus that angle. And I get 102.24. Okay, so I have that triangle 1, I have that triangle 2. Do you want to focus on triangle 1 or triangle 2? What do you want to do? It's up to you. Okay, let's go to triangle 2. Let's find angle B. How do I do that? 180 minus 77? No, not 77. Oh, you're focused on the first one. Okay, got it. Okay, so Tito wants to work on this side right here. 77.76 minus 70, and I get 32.24. Sweet. Can I now find angle B or side B? Yeah. Sine of 70 over 25 equals sine of 32.24 over B. Cross multiply. (25) sine of 32.24 divide by sine of 70. 1419. Can I find this area now? Do you remember how we found area yesterday? I'll use these three sides right there. What do I do? 1/2 times. Yep, times the two sides times sine of the included angle. I get 173.35. Let's do the other one. We now want to find this one. (180) minus 102.24 minus 70. Set up your law of sines. Sine of 70 over 25 is equal to the sine of 7.76 over B. Cross multiply. 3.59. If that was 3.59, then I would have a different area. 0.5 times 26 times 3.59 times the sine of 70, and I get 43.86. On your own right now, set this one up and see if you can first determine if it's going to be one solution, two solutions, or no solution. Go ahead, try on your own. Were you able to tell if it was 1, 2, or none? 1. Why? Yes. Very good. So that's part of your goal today and tomorrow through this worksheet is to be able to identify when it's going to have 1, 2, or none. So this is just a one solution scenario. So all we have to do is go 7 sine of 145 divided by 33. We get 0.12. We know sine can be equal to that. And I get 6.99. So angle B is 6.99 degrees. I can now find angle A, 180 minus 145 minus 6.99 is 2801. Now finding side A is easy. Sine of 145 over 33 equals the sine of 2801 over side A. These are the ones that you've gotten really good at because you already did your worksheet. You're staying on top of your assignments because you're an A-plus awesome student and you would not fall into procrastination. So I'm so proud of you for that. 2702. And now it's easy to find the area. Just simply grab an angle and 2 of the sides and go 0.5 times 7 times 27.02 times the sine of 145, and we get 54.24. Good job. You made it through today. That's the longest lesson you'll have the entire year. Our clock is timing out here at 33 minutes. You notice that you have 6 problems, right? You have 2 more on the front. You have 4 on the back. You're going to get today and tomorrow to work through those 6, okay? You're not going to get a new assignment tomorrow. But here's what I'll tell you. Out of those 6, there are 2 that are no solution, there are 2 that are one solution, and there are 2 that are 2 solution. So you have 2 of each. I'm not telling you which is which, but there are 2 of each. So tomorrow's the point where you got to somehow get through that confusion point of identifying where they are, and hopefully be able to have both worksheets then done by tomorrow and say, I'm ready to move on to easier stuff. Easier stuff.